Today, our talk, the importance of visuals in teaching Python and reducing bias. Let's get started. A little bit of myself. I'm a program manager working on renewable energy projects, background in architecture. I've been a course author in lots of different kind of software and coding and data subjects. And over the years, I have had a lot of experience trying to get people who are not familiar with the world of evolving technology to learn more about the technology stacks out there. So I'm a bit of a teacher, bit of a popularizer of Python as well. It's one of my favorite things. So that's a little bit about me. And the premise of this talk, but kind of the big idea behind it is that coding these days is everywhere. I don't have to tell that to our current audience. Coding is something that we all do, we use at some level. Some of us are very much expert at it. Others are novices, and the Python community supports everything in between. And everybody these days is kind of moving in this world of how do I use some kind of level of coding development to my advantage? And that's been my experience in my world is we want to use these tools, these open source tools, the data science packages in Python, the basic scripting in Python or JavaScript, or just knowing enough to take advantage of it in day-to-day projects outside the world of a dedicated software engineer, developer, that makes a big difference in how we get our work done. And part of my experience in the companies I worked at is we want our staff, just our general non-software developer staff, to learn this kind of stuff and the value of it, because it could help them out as well. But we wanted to teach them in a way that was relevant to them and made them feel like they were comfortable learning new things. Because not everybody was a student, not everybody was, had a natural tendency to this kind of thing. So how do we make them feel comfortable and not make them feel that they're excluded, like they are unable to learn this stuff? After all, a lot of this is low-hanging fruit these days. So this is a story of how this happened for one of the companies I worked at and how we got from A to B to Z, eventually a few things about taking coding in their hands. So with that in mind, let's talk about architecture. This is my background, is in architecture and design. I've had an architecture degree going back many years. And this might be what you think an architect does. They open up a piece of paper and they sketch on it and they draw the designs. And before you know it, the whole thing comes up as a building design, which is generically true. This is actually a very true depiction of architecture. This is what people do to this day. They'll take out the ruler, their fancy pens, and some sketch paper, and they'll go at the design. It's really awesome, cool. Very interesting discipline. However, this is also what architecture looks like nowadays. This is a 3D model. Of course, many people are familiar with the idea of using a 3D model to help design something. And architects are no strangers to this. Design engineers from many different backgrounds, structural design, mechanical design, you name them, they all do something similar. So this is where the models, something like this is a model that will then generate the drawings. So we don't just go and sit down and draw on paper the drawings anymore. It's actually a 3D model that will be the basis of all those 2D sheets and plans you see on some project, those big old rolls of paper. And that's how we get started, digital design. And this is not just a 3D image, it is also a database. Everything in this software will contain the information you need to actually take the design to completion. We'll talk a little bit more about that later, but be aware that current architecture and construction takes advantage of modern tools, just like any other profession. But we go even further than that. By that, I mean, we are going into this realm, and it's been the case for some years now, of analyzing our spaces and analyzing the use and function of a space. In this example, temperature analysis. Inside an office space, you can see the monitor and desk there, and how the fluid dynamics of heat in the space affects comfort levels, and how do we adjust for that. This is something an analyst would take from a designer, say, okay, we have this great space that we designed, fits a purpose. How do we then make sure that space is, on the one hand, comfortable and people feel able to get their work done in this space, but also it's not too energy intensive. We're not burning too much power in this area and this space, and we're being very mindful of the energy resources we put into this building. This is also part and parcel of a lot of architecture today, both as an additional service an architect might have, an engineer might have, but also something a client wants to make sure their building is performing adequately or required per code and zoning requirements in a given city. So this is something of, analytical models, which is very computational intensive. And we take a little further, we can also use the 3D models we have to do analysis. What you're seeing here is the green represents the intensity of people's movement in a space, in a floor plan. So this would be like a circulation diagram. The green is all the circulation hotspots you see. The more green, the more activity. Why is that important? So we know where people are going and we understand how close they are to exits, to stairs, where the relevant floor plan should build around people's activity levels so they're not too far away from, say, something they need, whether it's a restroom, equipment, you name it. And this is, again, a part of that simulation analysis. And also just design, just pure design. These kind of facades you see here, these woven patterns, these are popular all over the world. You see them in China, Europe, America, all over the place. That isn't manually modified. These are based on parametric tools and software that require some pretty good knowledge of how you can manipulate the fabric of a building's geometric design in a way that can then be constructible and then can be priced and built. So all these examples I'm showing you is based on, the last 10 plus years of how architects, engineers, and builders are trying to make the most out of the tools they have in order to get the most resources into their project in form of intelligence into their buildings and more capable buildings. And we want to open up a lot of these opportunities to the average designer. This tends to be a younger person's craft, is how we can do this kind of thing. But we also want the designers who are in their 30s, 40s, and 50s to at least have some coding ability, take advantage of this, because a lot of this is not necessarily out of the box, ready to go. Some of it is keystrokes on software. Others, you do need to know a thing or two about scripting and coding to take advantage of it in the most comprehensive way possible to open up these options. So we want to, the company I worked at, to teach people, teach our entire staff, this is over 200 people, how to do this kind of stuff consistently in a reliable way that they can feel comfortable. So our business case is we need to train users. The only problem is we didn't have capacity for a budget to, hire a bunch of software engineers to come on board and be a resource and be that kind of person you could talk to about this kind of thing. So we want everybody to learn instead some basic level of this due to our resource constraints. Depending on the company, they may have almost no budget for any kind of coding software staff. So you do have to be mindful of what you can and cannot do. But we found this is okay because we felt we could teach our staff, but we couldn't like traditional coders. We couldn't send them through a boot camp for 10 weeks. They had other work to do. Plus, there was this kind of threshold of stress of here's a brand new thing you haven't seen, whether that's the HTML, the CSS, the Python, the scripting, the tools involved with that, an IDE. The people I work with are very intelligent, but this might be something of a curveball to them. So we didn't want to say, okay, let's just treat them like they're coders. They're not. They think very differently. So how do we teach them the essentials of these new technologies and tools to add values to the work we're doing without making them feel out of place and putting them in a place that would make them feel that they are unable to accomplish what they want to do? After all, there is an intimidation factor. I think a lot of people listening can relate and think when they start learning something new or the first time I learned anything with software development, certainly true for myself, that it felt like I was in a place I've never been before. It was a bit uncomfortable, a bit out of my scope. So how do we deal with this intimidation factor? After all, if you're a newbie in this, if you a refresher on what a newbie feels like, you start with these examples where it gives you a very basic premise of what to do on like rendering a HTML page or running a script or whatever you're learning. And the example might start with something very straightforward and easy to do, and then expects you to kind of just fill in the blanks until you're complete, which is a great technique of kind of giving you this tension between the beginning and the end. If you're trying to really learn the subject matter well, which is something of a computer science background would do in class, wouldn't really work again with these seasoned veterans in their careers that may not be able to dedicate that kind of time and energy or just feel comfortable with that. So here's some basic ways we want to develop a learning curriculum. And the basic concepts was to remove barriers to entry, barriers to getting started, and make them feel, okay, like what's a great way to facilitate them? So therefore, the first step had to be non-intimidating. The first step had to be very accessible and compatible with how they think. And we also have to emphasize visuals. If you guys haven't tried, I think many of you have, diagrams and graphics to help people feel like they can see what they're working on, to come to terms with they're working on. Diagrams, graphics, visuals goes a long way. I'm not talking just like code and text in a IDE. I'm talking about real images. That goes a long way to bridge a gap with people who are not familiar with the subject. And also is to make sure you have methods of training that works for people. And this may not be the most obvious thing right away. You have to maybe do some trial and error. We had to do some trial and error. So sometimes it's an audio, as in you speak to them. Sometimes it's in person. Sometimes it's video and graphics. Don't make assumptions on what works best for other people who work best for you. So this was a bit of a learning curve, because after all, when people who are not familiar with code see this kind of thing, they end up like this. They get a little stressed out and like, what is this? What am I looking at? And we didn't want to make them feel that way. We wanted to make them feel like this is a learning opportunity that will make them feel a lot more enabled. So here's an example that might make sense of what we're trying to get at. Our favorite thing in math, the Pythagorean theorem, so many different ways of displaying how this works historically with just pictures. And I think a child can understand this, and an adult can appreciate this, of using either algebra, geometry, pictures, visual example like this. But you can also take this example of the Pythagorean theorem and convert it into code. And here's an example of how you can use Python code of importing math and setting some functions to create the same formula to return the values of the Pythagorean theorem. So we could, in fact, just use different ways to describe the same thing, where you start with a visual example and then say, okay, guys, you understand what this is, you know how this works, and then translate that into text code. And that's a great heuristic of connecting the dots here. And one tool we found that was very useful for connecting the dots, both literally and figuratively, was PyFlow. PyFlow is just visual scripting Python. I think some of you guys have seen visual scripting in different software packages to enable you to make some rapid prototyping without having to get into the weeds of a either code base or tool or language. And I've used PyFlow in the past just to kind of screw around with it and play around with a few things. And people tend to like this very well because they can, again, see it. They can move things around. You can, in this example, you can make a quick loop, the for loop, the steps and everything. And like they can see what they're getting into. There's less of a barrier of like, okay, what do I do next? You can actually see it. You can play around with it. It's touchy-feely in that sense. So that was an example I would show people how to get started on this. That was our breakthrough. So we had this breakthrough of people really like these kind of visual examples of coding. Again, we're not trying to fully engage software engineers. We're just trying to give them the basics to get started. So this is how we felt that people in our class, again, mature, career professionals who are already comfortable with a certain workflow can feel that they can get started. So that takes us to the meat of this, which is how do we take something like this 3D model we talked about earlier of these projects and get people to manipulate them with the latest tools. And one tool we found that actually is very similar to PyFlow and works well is called Dynamo. It's this plaid looking logo. That's the tool. This flow chart, we use the software on the right, R. That's not R for the coding language. It is R for Revit. It's a software that takes advantage of data and geometry. That example I showed you earlier, the buildings. So it's not just plain geometry, it's also baked in. How many doors are in your building? How many walls? What kind of walls? How big are the walls? How much concrete's in the building? All sorts of data is accessible. And the Dynamo software, and not DynamoDB, just does call Dynamo BIM, BIM for Building Information Modeling, enables you to do low-code tooling and scripting and prototyping in this Revit software environment that can generate this building on the left here. So with that in mind, we're trying to work with the building, and this building has data. How do we make it so a person can use that data quickly without knowing how to be a software developer? Well, here's Dynamo in a nutshell. This is what it looks like. It's not unlike many other visual scripts, low code formats. You have input nodes, some kind of process node of doing work, and then outputs. And be seen as 1,000 times, many of you. Same with this one, nothing different, very similar to the whole PyFlow example. So, basic arithmetic math, input is numbers 1 and 2. You do some process with the addition, and out comes the value of 2. What's great about this is something you can do in your head super fast, but I can also show somebody here, this is how it works. It's that going back to that Pythagorean theorem, we show people in a very straightforward way how these things work if they're not familiar with these tools. Because the reason we're doing this isn't to do math, we could do that in other ways. The reason we're doing it is to do something like this, where we can use our input, process, output to create geometric results, for example, to manipulate curves in the model. Lots of curvy buildings these days. And somebody can then use these tools. And again, these are only 5 nodes doing the very basic operations. The selection you see here of the curve is actually generated from the 3D modeling environment. And all we're doing here with the slider is putting more points along the way. Those points could be different elements on a building, could be trees on a walking path, could be a lot of things. And the process is pretty easy to follow, I believe, because people can see, okay, the slider does something. It's adding more things to it. The selection's coming from a model. They can make that model themselves. And they can see along the way, they can change the values so they can do whatever they want. This is the kind of thing that relates to how people want to access what they're working on and not, compile code and then see what happens. This is in real time. So it's a very useful way of seeing the results as you go and feeling confident that you can actually make changes to the environment and understand it. Again, removing barriers, moving a premise of a certain way of learning how to do things. And this example I'll walk through with you guys quick. It's a little more involved, but pretty straightforward, I think, of an input, process, output. We're trying to make a tower, a skyscraper, so we'll keep it very simple. It's going to be 4 corners. And I'll answer a question okay, there's a great question here. I'm going to answer towards the end of this explanation about design of an office. But for this one, example, the input is, how do we take the exact same concept with this Dynamo BIM system and create a tower, a skyscraper? And the idea is, let's have 4 points of a floor plan. It could be more, but let's keep it simple. Use 4 corners, connect the dots. That's a rectangle. And that rectangle can become our office building, our skyscraper. So I just did 1, 2, 3, 4 points by coordinates. 30 and 60 are the numbers. So you'd have 30 feet, 60 feet, 30 feet, 60 feet for your rectangle. Again, pretty easy to follow. You can change those values. At the bottom there is just the kind of content, floor slabs, curtain wall is your facade, something a designer would feel comfortable understanding in plain language they would get. So we combine the geometry of the floor plans with the content like the walls and floors we want to add, process that, and I'm not gonna go into too much detail here, but we're mixing and matching. We're adding the points together into a rectangular outline, and then telling the elements of the floors and walls, what have you, to then map to the places these outlines are. And then output on the top there, a wall at a certain height, and at the bottom there, a floor that is also matching the walls. And this is an example we show people that they can then take, rebuild, and do their own version of it so they can get this following result, which is on the left here, basic wireframe geometry of that rectangle, multiply times X number of floors. I think in this example, it's 100 floors. Very simple. And then we can push it into the model environment. Ta-da, we have our skyscraper. And this happens in seconds. And when they see, these designers see they can change their building elements very quickly and iterate very rapidly, their confidence just takes off like a rocket. And I think we all felt that kind of learning gratification at some point in our learning process that, oh, okay, I can do this. This is the kind of steps between the low barrier of entry, the software like that Revit that they've been using, with language like walls and floors they understand, with results they can just see with their eyes, that they can have an easy time getting the hold of and say, okay, I get it. I understand the integers connected to some mathematical process using vectors can then result in something like this that I can immediately use on a project. This is the kind of results that we can have a low hanging fruit and go from there. And we're not going to stop there. Of course, this is a Python event, and we're going to talk a little about Python. And what's beautiful is we could take something like Python script and actually apply it to the exact same thing. What's great about DynamoBIM is it has a Python editor built into it that you can take something like these, a basic script like this on the left, it can actually output a lot of great things in a concise and succinct way. So we don't have to have a bunch of boxes and wires all over the place as low code tends to provide us if we get a little more ambitious with the kind of work we're doing. In this case, it's basically just importing some stuff from both the operating system, the Dynamo environment, the Revit environment, setting some parameters, doing a couple of for loops, and then spitting out this three-dimensional object based on the for loop nesting. And this is how we kind of remove that barrier of entry to coding. We say, guys, there's a way you can do this with just a script, which is very involved, or we could just use the coding here. Again, plain language, XYZ is how we do the by coordinates here. As you can see in the PVC, it goes point dot by coordinates. 0, 0, 0, we say that's XYZ. Put some numbers there. That's the loop. And before you know it, you have objects in space. And this is a way for them to, again, see, okay, you do something on the left to get something to the right. You can manipulate it, you can change it. Very accessible because you're trying to meet them where they are. You're not starting off with Python and saying, okay, we're going to learn how to do all this purely through Python. And from there, you'll learn the rest. This might be way too much all at once. You have to kind of start from a place that's visual, touchy-feely with the low code that can make them feel confident and understand the concepts better or why we're doing this. And from there, we could take it further. This example is where you can mix and match between the elements you can select in your model, some Python script, and create some interesting geometry with steel beams on the right there, preview it, and be able to then push it into your Revit BIM environment. And then people can understand, okay, it's not just for fun, this is actually useful in a way that I can do some very sophisticated modeling and geometry, get some real work done for a project based on these kind of elements. So it's the kind of step-by-step process of understanding the core concepts, give you some easy to work with examples, taking the examples further and getting to like a real project. And then from there, we can go further and do big stuff. In this case, we see that building with the dots in the middle is generated by this preview in the front of the nodes. Again, the same concept, we're not trying to jump around too many different tools and skill sets. It's the same thing I've been showing you, the Dynamo BIM low code environment. They can generate an entire building through a different means, but same concepts, input, process, output that we teach people. They get something like this, which is generative design. This is iterating through many, many, many different variations of how a tower can be designed, and then plots it on a graph of, like, X and Y of what we're trying to look for. Maybe it's maximum space, maybe it's maximum lighting utilization. And from there, we can make more relevant design decisions for our staff that can then be used to build a project. So instead of me making 4 corners of a rectangle all the time, I can tell the program here, hey, do it for me. In fact, give me 20 corners. In fact, make the building step up as we go. So it tapers, so we have different patterns and it's not all monolithic. And then I say, okay, now I don't have to do it myself. If I know the right steps, I can make this happen based on the tools available. So they understand there's progression here. It's not just we learn one thing. They understand that this is the value of using these tools for not just developing something specific and handy off on the fly, but also analytical usages of the technology out there. And you can even include pandas and everything here these days. And talk about traffic patterns in the office. Here's how we figure out traffic patterns in the office. This is an example of how we develop a floor space using these blue lines on the ground. Here is the movement patterns you would have people through an office. All that stuff shifting around is furniture. What's the best way of aligning furniture so people have an easy time moving around? And this thing is doing real-time, analysis in 3D geometric environments with these usage patterns and showing the user, okay, here's the different things that can happen. Here's different adjacencies. You designer can then take the reins and control. I'll tell you right now, anybody who's been in traditional design, engineering, anything, they do not like the computer telling them what to do. They find it offensive, but they do like it when the computer narrows down things based on what they want. And that gives them a lot more control. So we say, okay, guys, based on something like a script we see in the bottom here, which is very extensive but functional, you too can create a environment that can discuss, or work with you to create usage patterns of traffic in an office. And this is a little more involved, of course. If you see those rectangles, they're all like many scripts combined into one, but that's learning curve. That's how you get from a basic point to a very more sophisticated point. You get some useful work done that helps understand what is the best floor plan, a real issue. I've worked on projects where you spend 6 months trying to rationalize this stuff as the project changes. The client has different feedback, situation changes. This is something that is actually immediately useful. And I'll show you something that's related to this that we worked on at the company I was at. So this is a project in the Bay Area. It's a library. And the idea was, how do we make a facade for a new library that on the one hand can shade the inside, but not too much on the other hand, so it doesn't feel dark and cold, but also looks great. So could you do this manually and just kind of go through multiple iterations in the design until you're done? Yes, that's how they used to do it. However, why not use these tools we had taught, these ideas of how you can take input, process, output, and make adjustments to get the best version of this facade. So one of the designers was taking the reins of this and made this example of how you could take these louver facades, modify them per the output. And you can see on the top left corner here, those different variations is a result of studying these different louver inputs, but he didn't do it manually. He was trying to get the right amount of light and a decent design. And he did it with this process. It's a very similar system. It's a low code that, same thing as what we saw before with Dynamo BIM, is called Grasshopper for Rhino, also popular geometric modeling system. Think Blender. When you think Blender, it's very similar in that regard. And again, a lot more steps here to the point where you can't even see the entire script that we had to zoom out to a portion of it, but exact same logic. We said, okay, we have the input, process, and lots of process, lots of transformations, lots of needing to make modifications and controls. There's actual literal switches in here. Now, if you're a regular software engineer, you might do it a different way. But for somebody who's just trying to get some modeling done and do it in a way that's concise, this is actually a pretty good place to be. And I'll tell you right now, they find this very aesthetic. It's almost like you're trying to wire something like a server and make it as clean as possible. It kind of relaxes them a little bit too. Just FYI there, people like to clean things up. just to make them feel like they have progress. So this actually worked out very well, that we got the results here. That's on the left here is a zoom in of that script, so we can actually see the controls that can then generate a comfortable space inside the floor plan of the library we were seeing earlier, and then give us real information about, okay, based on the orientation of the building to the sun, the depth of the floor plan, the height of the level of the building, we can understand if it's too hot, too cold, do we need more louvers, fewer louvers, do environmental analysis to get results. And this was actually applied on a real project. And the idea was, let's do this, teach a few kind of early adopters who are comfortable with this kind of thinking, and make it a case study in the entire company of how you can use these tools to actually apply all sorts of principles of environmental design, design optimization, and control by architects and designers, so that we can apply it to other projects. That's a value add for us to these clients and owners of these projects, so they understand we're capable of this, part of our regular design process, and we don't have to have a limited version of this or have to spend extra on outsourcing it. If we can get 90% of the work done ourselves, we can dial it in pretty well before we go to anybody else. These are the kind of step-by-step leveling up that we did to get some real work involved, and it continues from there. People who tend to have this kind of level of sophistication also want to learn thoroughly, then how can I make like a UI of a tool set that I can just send off to my project manager who can just click on things. That's kind of the software engineer coming up alive in them, where they not just doing the back end themselves, but also developing tools for others to distribute. So with that in mind, what can you do to facilitate these kind of improvements? Well, like you saw me do, use diagrams in your documentation and training content. We use lots of diagrams like the ones I was showing you for, what is a low code? How does input process output work? An example like that really clicks with people. It's easy to see, it's easy to pick out in like text documentation. Would be a bit of a wall of text compared to diagrams. Diagrams are very easy to digest. So think, how can I use visuals and diagrams to get a point across succinctly so people have a frame of reference? That's very useful. And there's lots of that these days available if you look around for some of the examples we saw today, like UX, great stuff there. And be comfortable, if you are in that world of code, text code all the time, be comfortable and step out of there and use graphics and visuals like low code to communicate. PyFlow is a good example of that, because it's basically just Python, but low code. So if you're trying to teach somebody, maybe a young class, maybe professionals like I'm doing, where they're not familiar with this environment, don't make the assumption that's where removing the bias comes from. Don't make the assumption that they already know the basics of this. They probably don't, but you can level them up to get there. So it's a bit of a learning curve for them. And I would highly recommend contribute to open source projects. There's a lot of great programmers and developers and advocates in these events. There's lots of tools out there that could use some attention from you. We'll show examples for that, because I try to do my best to give back to these open source projects, whether it's Python or one of the tools we're talking about. And just simple as, user feedback. I do user feedback for the Dynamo BIM environment, and just, providing samples of my content to the community. It could be that simple. So to repeat what we learned, remove your barriers, make the first step non-intimidating. So very, very easy steps we saw earlier to get them going and think, okay, I could do this too. Emphasize visuals and graphics. Works great. It's fun. I think people enjoyed what I was showing off here to some level, I hope. And the more methods of training, the better. So that when you start training them, you actually go from 1.1, 2, 3, 4, 5, 6, not just give them a challenge right away. This is not leak code. This is just trying to get people to a level of productivity. And here are some resources you can use. Again, PyFlow is another example of that. Very cool. There's PyFlow, FLOW, and it's on GitHub. And this is a great example of diagrams. If you go to their GitHub page for PyFlow, they have tons of GIFs like this, like dozens of them explaining how it works for all sorts of different operations. It's just fun. So go check it out if you guys have a chance. It's a really awesome GitHub. Highly recommend it if you ever want to see what's possible with like these kind of tools. If you want to see more about Dynamo BIM, the one I was showing you the most today, Here's a little more sophisticated modeling where they're making a kind of a canopy tunnel structure. Go to dynamobim.org if you want to see how this works. It's a very specialized software for a very specialized platform, but it is interesting to see what people can do with it in many different ways, from geometry modeling to data operations. It's very flexible. It's a very cool tool that I show people all the time. And if you guys aren't into all that, if that's not your world, Blender also has this. Just by any kind of popular software has these kind of low-code visual tools. And with our favorite Blender cube here, you too can make modifications and transformations just like we did in the other examples today. And I had some example, I can't show them today, but I have examples of that happening with Blender tools. Same concept. So here's some examples to check out. Blender.org. This is geometry nodes. If you guys are interested, Blender geometry nodes, very cool stuff. Lots of amazing examples we can do there. And here's some more: PyFlow, Dynamo. There's some other fun things we used to teach people: PyWeek, Pygame, Scratch, Python Tutor, basic things that people have an easy time learning. So highly recommend you check these out. I think the slide deck is available within this talk in the LoudSwarm, so check it out. I'll make sure you guys have access to it. And if you want, please hit me up. If you have any questions, QR code LinkedIn, no Rickrolling this time. And Twitter, LinkedIn, GitHub, you can find me at Tadeh Hakopian. I'm SEO optimized. I don't think too many people have that combination of letters, so reach out and find me. If you have any questions, want to learn more about anything I talked about, just want to chit chat, by all means, feel free, because I'm here to spread knowledge and learn as well. So I'd love to connect with you guys. And of course, thank you to the Python Web Conference staff. You guys are amazing. 6 feet up. You guys are amazing. It was a pleasure to be here, present, and also learn from all the other great presenters. So let's keep the conversation going. There'll be a follow-up session, and there's Slack. So thank you so much for joining me in my track today.